Hey class, Mr. Houston here, back for the chapter finale of right triangles, where we get to put everything we've learned over the last 6 lessons and put it all into one, called solving right triangles.
Ooh, I bet you're real excited.
It is going to be lots and lots and lots of fun. The key concept we've kind of hit on this yesterday is what's known as the inverse trigonometric ratios, and basically what that does is allows us to take the inverse tangent or the inverse sine or the inverse cosine of our ratios and figure out the angle measures that are missing in any given triangle. So you'll still kind of set it up the way we did in the last 2 lessons, but now inverse tangent is like the opposite of tangent, opposite operation of tangent. So it's kind of like multiplication and division or addition and subtraction. So we will start out with an example just like that, using the inverse tangent to find an angle measure. They want us to find the measure of angle A to the nearest tenth of a degree. So we are, again, using tangent. We are talking about angle A. So we are here. Again, first thing you need to identify is your opposite and your adjacent. Notice how, yes, we have the hypotenuse, but there's no number involved there, so we're not going to use it. So the tangent of A is opposite over adjacent, so 15 over 20. We can simplify that down to be the tangent of A is equal to 3 over 4. And then essentially what we are going to do is we are just going to put A by itself, and we are going to find the inverse tangent, so tangent to the negative first power of 3 divided by 4. And again, in your calculator, because we aren't going to try and memorize these things, you'll usually have to hit the second button to get the inverse tangent. 3 divided by 4, hit the equals button, and you will find that A in this case is equal to 36.87 degrees. So angle A is 36.87 degrees. From there, you could figure out what angle C is to figure out all the side or all the angles in the triangle, and you could also use Pythagorean theorem to figure out the hypotenuse in this triangle. That's what we're building up to, is having to find every missing measurement in a given right triangle. So that's inverse tangent. Inverse sine and cosine work exactly the same thing. This time, we're not going to make you set up the ratios. We're just going to give you sine of A equals 0.87 and cosine of B is equal to 0.15. All, again, we're going to do is take the inverse of both of those. So in this case, we'll just say A is equal to the inverse sine to the negative 1 power of 0.87. Again, in your calculator, second sine 0.87, hit enter. You'll find that that's 60.46 degrees. We'll do the same thing with cosine of B. So B would be the inverse cosine of 0.15. Plug that into your calculator, and you'll find that that angle is equal to, we already found A, we're finding B, is equal to 81.37 degrees. So essentially, using these inverse functions, you still have to set up the ratio, but then after where we stopped yesterday with just the fraction, you are now going to take the inverse function of whatever that fraction is. So let's put that all together. All right, so solve the right triangle. Anytime you see the word solve the right triangle, they mean you have to figure out every missing piece of information that there is in this problem. So for example, if you look over at this picture, you'll see that we are missing, we're missing this leg here. We are missing the hypotenuse, and we're also missing this angle. Make it easy on yourself. Find the easiest information first. And in this case, the easiest information that we're going to have is to figure out the measure of angle B. So the measure of angle B is going to be equal to, remember, a triangle adds up to 180 degrees. We'll subtract the 90 for the right and the 42 that is in angle A already, and we will find that the measure of angle B is equal to 48 degrees. Okay, now we must figure out, and now that we know this is 48 degrees, you have options. You can use whatever you want to figure out side length CB, or you could figure out side length AB, whichever you would like to do. Since we've already kind of talked about finding side length CB, we're going to talk about finding the hypotenuse when you're missing a side. So we are going to start with angle 42, and what we are going to do now is identify, this is our opposite, this is our adjacent, this is our hypotenuse. So we have sine, cosine, and tangent. Remember, sine was opposite over hypotenuse, cosine was adjacent over hypotenuse, and tangent was opposite over adjacent. So if I want to find the hypotenuse, I need to use the side that we already have, which would be my adjacent, which means I'm going to use cosine. So we will use the cosine of 42 degrees is equal to the adjacent, so 70 feet, over the hypotenuse. Remember our shortcut from yesterday, actually from 2 lessons ago, that we've kind of talked about. Whenever this is in the bottom, you can bring that out to the other side. 70 will stay on top, and then the cosine of 42, or whatever that is, will go on the bottom. You'll simply plug that into your calculator, and you will get 94.19. So side H is equal to 94.19, and in this case we're talking about feet. So we have angle B, we have side H, we now need to figure out side CB. Again, a couple ways you can do this. If you want to use Pythagorean theorem, now that we have 2 out of the 3 sides, you can. I'm going to use another trigonometric function to do this. I am going to use tangent this time because tangent is opposite over adjacent. So the tangent of 42 degrees is going to be opposite over adjacent. I will multiply both sides by 70. And my opposite side in this case will be equal to the tangent of 42 times 70, which equals 63.03 feet. So there are many ways to go about figuring this out. It all depends on what you want to use. These are just some of the options. We can obviously talk about more options in class, but again, anytime they say solve the right triangle, you have to find all missing pieces of information. So let's move on to our final example, and we're talking about a real-world problem. So suppose your school is building a raked stage. Not sure exactly what that means, but the stage will be 30 feet long from front to back with a total rise of 2 feet. A rake, or an angle of elevation of 5 degrees or less, is generally preferred for the safety and comfort of the actors. Is the raked stage you are building within the range suggested? All right, so what we are trying to find is we are trying to find this, let me get a marker here. We are trying to find angle X here. So we are going to employ the inverse trigonometric functions that we were just talking about. So from this angle, we are going to identify that this is our opposite. This is across from the 90-degree angle, so this is our hypotenuse. So again, our options, SO, CA, and TOA. So notice we have the opposite and the hypotenuse, so we need to use sine. So the sine of x is equal to opposite over hypotenuse, 2 over 30, or we'll call that 1 over 15. Remember, to find an angle measure, we are now going to take the inverse function, in this case the inverse of sine, onto both sides. Plug that into your calculator, 1 divided by 15. You will find that the angle measure for x is 3.82 degrees. So they said they prefer the angle of elevation to be 5 degrees or less. This is obviously less than 5 degrees, so this is well within the range of the suggestion. So again, this is a compilation of everything we have talked about so far. Again, if they say solve for a right triangle, you have to solve for every part of that right triangle. Okay? So again, I expect you to have questions, but hopefully some of this makes sense. Hopefully you're able to understand what we have to do and what we have to solve. If you have questions, bring them with you to class, and we will see you then.